Ladies and gentlemen, boys and girls, and those of you still on the fence, welcome back to another episode of Derailed, courtesy of Archaic Skids. I'm, of course, your host, Archaic Skids, and we have Kim Ruff with us today. How are you, Kim?
I'm very good. How are you?
I'm doing great. Why don't you tell everyone who you are that doesn't already know, and just a little about your background.
Sure. Okay. So for the context of this conversation, since we're going to be talking about more of the mechanical and mining end of things regarding uranium mining and things that go into nuclear power, the relevant aspect for all of you is that I have spent the past 15 years of my professional career working in some capacity or another in fabrication, whether it's steel or plastic. One company I worked with for about 11 years, which is actually my family business here in Arizona, does high capacity steel fabrication, which means that it has the ability to manipulate and work with heavier steel, larger pieces of plate, things like that. So we're kind of your last stop shop here in Arizona before you start going and subbing it out to California or Utah or other states. And our bread and butter was typically the Arizona copper mining industry. We made a lot of products for them, including anode furnaces, grizzlies, which are our industrial sized strainers, hoppers and bins, things of that nature. So in that context, I worked as an outside salesperson, estimator, and project manager. So I was directly on mine sites working with our stakeholders. I did reverse engineering of things like dust collector stacks. I can do drafting and then managing the project as it went through the shop before ultimately delivering it to our clients. So that's in that capacity. The other job that I worked at was I was an operations director for a mid-sized steel and plastic fabricator. And what we did is we built products for the semiconductor industry. And the semiconductor industry is absolutely very relevant to mining because of the fact that it uses silicon. Silicon wafers are a semiconductor, hence the term. And then that is ultimately what goes into making your microchips that go into making your computers and cell phones and things of that nature. So that's my whole background, is working in those industries in that capacity. And then politically, most recently, I had thrown my hat in the ring to run for Arizona State Mine Inspector, which in the state of Arizona, we are the only state that has this as an elected statewide position. And functionally, what the Arizona State Mine Inspector does is they're responsible for going on site twice a year to open pit surface mines and 4 times a year to underground mines, and doing an inspection to make sure everything is in compliance and that safety standards are adhered to. And then a subcomponent of that is that they also handle reclamation, which is where we get into introducing closed mines back into the environment to make sure that it makes the environment sustainable. And then we deal with all the abandoned mine shafts that are littered across the Arizona landscape because we are a mining state, no doubt. And we didn't have the standards before and didn't take very good care to close those out. So people will go off-roading in the desert and they'll be like, oh, there's an open mine, we should explore. So that's not good, people, don't do that. And then the fourth component, of course, is training people to make sure that they understand federal and state standards and that they adhere to those when they go on site so as to mitigate or avoid accidents and fatalities.
Awesome. And you were kind of burned out of that opportunity by the Arizona GOP, correct?
Yeah, it's a bit of a pity, but the long and short of it is that for many decades, so the way that it's defined is that the position was established with our Constitution when we became a state in 1912. And it just basically says that that position is going to exist, and ultimately the first legislative session would determine the qualifications. And the qualifications were essentially people that had worked in an industry that was under the overarching cap of MSHA, which is the Mining Safety and Hazard Association. And that was actually founded in 1977 under Carter. But anyone who had affected by and had been under that wider cap was eligible to run for the Arizona State Mine Inspector position. And since I worked as a contractor for upwards of a decade and had to go through all the training and I was constantly on mine sites, I did qualify. But just most recently, because the sitting incumbent is timed out and ineligible to run again, the GOP had floated legislation that essentially changed the qualifications to crowd out anyone who is not in management and or a contractor. So only people who have worked in a management capacity for 4 years at an Arizona mine site, in addition to some other requirements that I do meet, are eligible to run. So there were two people at the time that this was voted that had already put their information in and were seeking nominations, gathering signatures to be on the primary ballot. And it was me and someone with the GOP. And I am no longer eligible to run. So it's just this one person who worked for about 4 years for Sarco, which is a Arizona-based, well, it's technically owned by Grupo Mexico now, but it was an Arizona-based mining company as a permits manager. So he's the only one who's eligible to run. So
yeah, so for those of you in the audience that think that it's Democrats that make sure to goof around with stuff to keep people from getting into these elected positions, it's both. The uniparty definitely works together on these situations. So your family business and what it was that you manufactured, obviously, based on the context of this conversation and the mining impacts required for uranium and things that, of that nature, for nuclear power is where our primary conversation is. Your family business would have required a massive amount of power to run its operation. Is that correct?
Yeah, to some extent, yes. I mean, it is fabrication. So you're running overhead cranes and you're powering up equipment like a plasma cutter and horizontal plate rolls and things of that nature. So yeah, there is a lot of power involved in making those things happen because you're manipulating very thick, high tensile strength pieces of steel. So
right.
Yeah, there is a lot of power.
Right. And then that also doesn't cover the fact of the actual steel manufacturing requires a huge amount of power as well.
Right.
And it's very expensive to manufacture steel in America now because of power costs and things. There's other factors, but obviously power is a huge one. One of the things that I say is manufacturing in America could be drastically made cheaper with more nuclear power plants.
Yes, yeah. I mean, the yield on nuclear power is exponentially greater than any other power source, and it's a lot cleaner too.
Right. One of the things is, and I've got a lot of questions about this in the conversations with Mark Schneider about nuclear power. And a lot of people have asked about the environmental impact of mining and the mining operations and also manufacturing the fuel. I know you're not an expert in all of those things, but could you give us an idea of what the actual environmental impact of mining, at least from the state of Arizona?
Yeah. Excuse me. Yeah, it needs to be understood, and this is something that, I will never deviate on environmentalists with, which is that mining in its own right, by its own existence, is going to obviously have an environmental impact. You are literally digging into the earth at variable degrees, depending on what kind of mineral resource you're trying to get. But you're digging into the earth and you're displacing rock, you're breaking it down. And then the process of mining involves myriad things. In the case of copper mining, for example, which is what I know the best, not only are you doing blasting. So in an open pit surface mine, typically the way it goes is that they'll do a core sample. So they'll dig down to find out where this ore body exists. They'll map out a plan, including like how they're going to blast it and open up the surface mine to make it function. They'll take out this, they'll extract it after blasting it, and then they'll run it through the milling process to break it down to a concentrate. And then to get it even more refined, what they do is typically either smelting, just heating it up and then using acids and things to separate out the mineral, or they do what's called sulfur extraction electrowinning. And that's typically when they put it in a chemical bath, and then they use electrodes to bring that metal to the electrical charge. And that's how they separate it out. So in the state of Arizona, we had a couple of smelters, but to my knowledge, none of them are presently active. And part of that has to do with the fact that there was such a downturn in the economy, the necessity of using a smelter was no longer there. But more importantly, more critically, is that EPA standards have made smelting far more difficult. So what they had been doing was taking this concentrate, selling it to China, and then China, because they have much, much more lax standards, would do the smelting and refining, and then we would purchase it back. But for a long time, there was a huge glut on it. China had purchased so much of this concentrate that it did not, the need for it wasn't here in the mining industry, which led to a bit of a downturn. But things are picking back up. As you'll notice, commodity prices are just going through the roof. Like even lumber's up 1,000%.
Yeah.
And it's
Yeah.
because industries are picking back up and that need is there again. So to go back to what you were saying, all mining has an environmental impact. And that's actually where that reclamation portion comes back, because what you have left over are going to be things like tailings ponds, which is a big water-based bath where these tailings, the little rems left over from having done the milling process, will be. Or you'll have chat piles. And chat piles are, those big dome-shaped piles of just leftover non-economically viable minerals. No mineral grows in a vacuum. Like, no crystals are developed just wholly independent of. They're always integrated with other elements, other minerals. And so what mining involves is separating out that economically viable mineral from the rest of them. And sometimes when you do that, you end up with a high concentration of a non-economically viable but potentially toxic mineral. So, you and I talked about this on the phone before, but Pitcher, Oklahoma is a really good example of this. Pitcher was a lead and zinc mining town, and they had these huge chat piles of what was left over, and all of that leftover mineral in high concentrations got leached into the groundwater supply and started to poison people, started to make them very sick. So ultimately the people through eminent domain were moved out of Pitcher and it was disincorporated. But mining does have an environmental impact, and that's something that we need to be cognizant of.
Right. And to that, when we've done the shows with Mark, one of the first things that Mark had discussed was the accidents, because the accidents happen. This is just a fact of life. And I had done some research, and I believe I had sent it to you as well, that the largest, mining spill or uranium spill in American history was in a place called Church Rock, New Mexico. Were you able to find any information on that?
No, I'm sorry. I actually didn't get your questions, and I'm sorry for that. But if you know about it, by all means, do tell me, because I'm curious.
Well, I mean, basically, I was, unfortunately, when you're looking into situations like this, especially in today's environment, you basically only get the negative feedback, and so everything's written in a negative light. It requires quite a bit of digging, but so Church Rock happened in 1979, and basically it was a tailing situation. They had built a dam out of the tailings. Obviously, that's a pretty normal thing. Not as much so anymore, but it was then. And the dam had some stress cracks. The company that actually owned it did not repair those, and so the dam broke, and the tailings, it was a little over 1 million gallons of uranium tailings went into the river, and it made it all the way down into the county that Albuquerque, New Mexico sits in. It actually made it all the way to Arizona, to the county that Phoenix actually sits in.
All right.
So, yeah, but it was described as the largest basically nuclear accident ever, and it caused some environmental impact. Obviously, they say that it's still causing that impact as of today, but the Navajo reservation and their version of, I guess, MSHA, OSHA, they have stated that the impact was only really felt for 3 to 4 years. Now, they were never properly taken care of, and the damage done to their property and their people. However, it's funny when you read the articles about it, they say, well, it was twice as bad as 3 Mile Island disaster. Okay. But the problem with that is that when you actually talk to someone who knows nuclear technology, and RIM is what it's called, 3 Mile Island was 3.2 RIM, was essentially what the closest people around them were exposed to, as far as radiation goes. And when you get an X-ray, a dental X-ray, that's 3 RIM.
Right.
So essentially, when you say it's twice as bad, it's like, oh, so you got a couple X-rays,
Right.
As far as
Yeah,
exposure
that's something
goes.
that needs to be clarified, most definitely, because I think that when people think of uranium, they think that all of it is radioactive, and the actual components of it that are radioactive are select isotopes. So in the case of what's typically in, nuclear power, it's U-235 is the isotope, and U-235 and a piece of uraninite, which is the mineral that contains, the uranium mineral, that is like 0.72% of the entire composition. There is actually
Right.
a big question about this because right now in Arizona, and for good reason, this is a concern because of what happened with the Navajo Nation and how a lot of the individuals there had been misled and lied to by both the company as well as the government about the risks associated with uranium mining, and were exposed and made sick as a result of it. There's a reintroduction of that question about should we do uranium mining in Arizona, particularly around the Grand Canyon State. One of the things that's floated by environmental groups is a concern about poisoning, having these radioactive materials in the Colorado River.
Mm-hmm.
But the reality is, and this is according to the Arizona Geological Survey, is that as it stands, just because uranium is already soluble and because it typically ends up in what's called a roll front. So when there's water that passes through, the uraninite will end up toward the front of it. And those are the most economically viable bodies. There's already 40 to 80 tons of uranium that goes naturally into the Colorado River as is. And that whatever impact would happen as a result of mining, which is not going to be right on the rim or inside the Grand Canyon itself, but adjacent to, would be negligible. And that's something that needs to be understood. We think of radioactive materials and we, obviously we think of things like radium and what happened to the radium girls, or what happened to Marie Curie for her, naivete about what that impact would be on her body and how she developed that blood disease as a result of exposure to radiation.
And it killed her husband.
Right. We think all radioactive materials are a bad thing, but it's not necessarily. You're right. You have to look at what is that in comparison to other types of exposure, and is that greater than to the level that it would be potentially harmful or lethal before we start saying it. When we just say uranium is in the water supply, people will panic because of how toxic radiation is, but it's already naturally in there. Like we're already exposed to some degree of radiation just because we exist on planet Earth.
Yeah, exactly. And I was actually able to do some research, and I wanted to see what is the difference between having radiation in water, for instance, right, or uranium, which I also did find out that it's naturally in basically every river that you find uranium in the ground. It's already in the water, but compared to, say, an oil spill, it is not even close to the same level of natural or of disaster type situation. And so I wanted to cover that. That is the largest accidental release is how they refer to it. And that was in 1979. Some very strict guidelines were put in place after that, as far as keeping those tailings ponds. You're not allowed to use the tailings themselves to build the dams anymore. So they essentially solved that issue. And so when you have people go, well, what about? Well, okay, but the situation is things will happen and you don't know what's going to happen until it happens. So all you can do at that point is risk assessment. And I don't think people understand this because obviously there's a major push, both politically and environmentally, to use solar panels, wind, things of that nature. Now, can any of those products be made without mining?
No. In fact, the basically what we say in the mining industry is if it can't be grown, it's mined. So all of those base elements, they come from mining. If you're using steel, which is an alloy of several different base elements, those are going to come from mining. If you're using, batteries, like things to create batteries, well, all of that comes from base elements that are extracted through mining. So really the question is there a better way that we can get those materials? Can we grow them in a lab, for example? You can do that with sapphire, and that's something that the semiconductor industry does, is they grow sapphires in a lab to be used in the fabrication of, their cell phones and computer chips. But that sort of thing, everything, like if it's not grown, it's mined. And that's something that needs to be understood.
Right. And that's one of the primary things that I keep running into with people when trying to explain to them that, if you want to buy a Tesla, that's great. And you think you're doing good things for the environment. Long term, maybe you are. There's an argument to be had there, but you can't have that car without mining. And what I don't think most people understand is that the majority of power plants actually run on either coal or natural gas. are the two primary fuels. They're not actually powered with solar panels. They're not powered with wind. That represents a very, very small fraction of the overall electricity used just in America. But so one of the things is that it would, to me, and from I'd like to get your perspective on this. Instead of mining to make solar panels and make wind turbines and all of those things, if you're mining uranium or plutonium or thorium to build nuclear power plants, then that car is actually much better for the environment. But you still have to mine. There's no way you can't even have the car. And I don't think most people understand the actual impact required to even make a solar panel.
Right. Yeah, there's a couple of things that seem to be lacking in the conversation, and it's understandable because a lot of people don't think about this. But one, of course, is the supply chain. Everything that you acquire, everything that you own, it comes through a supply chain, and you have to get the base materials. One of the most prolific, in fact, the most prolific man-made resource is concrete. Concrete is a combination of aggregates and cement. And cement is a combination of aggregates that have been put through a kiln. They create clinker, and then that is mixed together with these broken up rocks, all of which come from mining to create concrete. Concrete is an amazing resource, but the fabrication of clinker is actually what accounts for 30% of our carbon emissions. So is there a better way to do this? I mean, we see so many buildings that are getting away from using lumber or using necessarily steel, although they do use steel reinforced concrete as a way of maximizing the output while minimizing the materials used. But all of that comes from mining. So you need to understand where this stuff comes from. And then as a consumer, you need to look at the companies that are responsible for the commodity end of things and evaluate their environmental practices. Companies that are being watched by the consumer and will be hit in the pocketbook by us not patronizing them will be much, much more likely to adhere to better environmental standards than previously. The other thing that needs to really be understood is that there's an exponential difference between how we handled mining 50 years ago or 100 years ago versus how we do it now. So much more of it has gone to being able to extract even more mineral out of it. You're having mining companies go back and revisit those tailing piles or those chat piles and reprocessing it with better, superior technology that can get much, much more mineral yield out of it. And they're also recognizing that some of the other minerals that were in that chat pile are also economically viable. So that's a really good way of kind of mitigating that leftover disaster or potential disaster. So those are kind of two things. The third thing, and this is something I actually just recently learned, and I thought it was so fascinating that I wanted to share it with you guys. Mostly when we think about the internet, we think about like the cloud and how it just sort of exists in this nebulous concept. But the reality is that every time we use the internet, we are running a series of fiber optic cables across the bottom of the ocean floor that are very heavily insulated, very heavily protected. And every time we do a Google search, that accounts for the same amount of energy used to power an LED light bulb for a month. And all that energy, like this is the second law of thermodynamics. Energy cannot be created or destroyed. It can only be transferred. So it had to come from somewhere else. And that is part of our carbon footprint. Everything we do causes a carbon footprint. Everything.
Right. One of the things that I see from the environmental activists and groups, and I think the politicians, some of them maybe believe it, most of them just want to get reelected, but is that I find it just insane that someone will tweet out some environmental nonsense on their $1,000 iPhone. And it's like, okay, you know that, and a lot of times it'll come down to some business, say a mining operation in America, and it'll be, well, they don't have to follow any of these safeties. It's all profit over everything, blah, blah, blah. Okay, fair. But what happens when you get these politicians to ban or outlaw or restrict these businesses so intensely as to, like you said, where it shuts down the copper industries, essentially, well, they don't stop doing it. They just ship it to China or India.
Exactly.
And they don't have the environmental regulations and restrictions that we do. So it's hard
It's
to
passing the
get these
buck.
people. Yeah, it's hard to get these people to understand that by trying to force politicians to save the environment, you're actually making things worse.
Right. All you're doing effectively is creating what's called NIMBY, which is the not in my backyard concept. Like it's out
Right.
of sight, out of mind. But the reality is that the earth is a closed, contained, sorry, flat earthers, globe. And because it's closed and contained, what happens to the environment in one part of the world will ultimately have an impact in a completely different part of the world. Political boundaries don't mean shit when it comes to the earth. And so
Exactly.
if we're giving it to China and China's smelting it, which is maybe not the best process that we could be using, we could explore something better, then all we're doing is just transferring the liability, but we're still going to be impacted by it.
Right. So it would be a much better concept to incentivize those businesses to figure out better ways to do it and do it in a safe, responsible, respectful manner here in America.
Exactly. Right. If we want to get a place where we are energy dependent or energy independent nation where it's only us supplying our own energy and we're not beholden to other countries who may or may not have political regimes that are going to be in conflict with us, the way that we have to do that is that we have to open up the marketplace and allow entrepreneurs and innovators the space to be able to create these alternatives. And that's where we as consumers come in. We have to be very, very educated about our supply chain and who is generating what base commodities and materials and determine whether or not we want to support them by paying for those products. So, for example, and I want to say something and make it very clear. Absolutely no knock on people who are environmentalists, because I think that is such an essential conversation that needs to be had. And I'm sure
That's
you
not what I
agree.
was trying to do. Yeah.
Right. Yeah. So like I completely think that it's incredibly important that we look at the environmental impact of everything that we do and see and assess and determine if there's a better way to go about it. But we can't legislate our way to that. We have to allow businesses that freedom and make that decision in a democratic way, which is, of course, through the marketplace, to kind of come up with those solutions. And generally they do. The problem with solar and wind is that both of those are, of course, they come from mining, so there's going to be an environmental impact, and then they have a much, much lower yield. And it's such a low yield in energy that our government has taken to subsidizing those industries. So in the case of Arizona, we see a lot of solar companies come out here, many of whom are actually from foreign countries. Like we have a lot of Canadian solar companies. They get a huge taxpayer check to come out here and set up shop. And they buy a huge warehouse and they fill it with all this neat automated equipment. Like there's nothing cooler to me than an automated welder. And they have all this stuff. And then they go to all the businesses adjacent to them and then have them do the work. But the work is not going to have the market demand. And so they ultimately end up going bankrupt and in the process take other fabrication facilities with them. It's just not a very high yield on energy. Nuclear has an exponentially higher yield. For a small portion of uranium 235, you're able to get a huge amount of energy. Nuclear, Palo Verde nuclear power plant, which is the one that we have out here in Arizona, that one has 3 reactors, and that is able to supply 54% of the energy needs of the Phoenix metropolitan area. And to put that in perspective, Phoenix is the 5th largest city in America. So I know you guys would think not so if you flew in and you saw our downtown because it's like 3 buildings, but we're a huge megatropolis and we need a lot of energy in order to survive in the Sonoran Desert. Nuclear is the way to go, and nuclear doesn't have carbon emissions because they're not burning fossil fuels.
Right, exactly. And I think it's important for people to understand that I believe Mark said there are 90 nuclear power plants that are operational at any given point in America. And to put that in perspective, that represents almost 30% of all of the power used in America. And it's actually going up because they've gotten better at processing everything. So nuclear is actually, even though we haven't seen a lot of new plants built, we've actually seen power production increase from those plants. And there's great new technologies that they're working on. But 54% from a single, well, it's 3 reactors, but a single site is insane to me. I mean, that's a huge amount of power,
right? And
for a very small footprint.
Right, and Palo Verde doesn't just power Phoenix; it also powers southern Arizona as well as Southern California. So it provides a lot of energy.
Right.
It's a very big deal. It's also, of course, during 9/11, it was very well guarded because we were like, if they attack it, we are so boned on so many levels. But
you might be surprised. No, you wouldn't. They, that was one of the
I meant mostly just making the grid go down.
Oh, sure. Yeah, that would be problematic, obviously. But people, that was one of the concerns that a lot of people had, and I asked Mark about it, and he essentially told me, like, yeah, you're not gonna damage them. Like, you could hit it with a missile and it doesn't matter. So it's not one of these situations where if they fly an airplane into it, they'd have to shut the reactor, down temporarily to clean up debris. But it wouldn't be what people think it would be.
Right. Yeah, not necessarily going to be like a giant mushroom cloud in the middle of the desert.
No,
but yeah, in the case of Arizona,
I just meant that because we're so dependent on the power grid in order to make life hospitable here, because we get temperatures up to 120, 25 degrees, and people cannot exist without having central cooling. It would be very, very bad in that regard. That would be probably the very worst thing to happen here.
Right, absolutely. And so, keeping it heavily guarded is a great idea. And just for people's own knowledge, all nuclear reactors in America are heavily guarded. They increased their defensive capabilities after 9/11, obviously for obvious reasons, but they are heavily guarded. They always have been. This is not a new thing. Now, I want to focus on, the mining. One of the mining aspects of it is that there is a particular element that is very, very, very much needed in order to make solar panels, primarily the battery backup systems and the batteries for Teslas and all of these electric cars. And that's called Cobalt. And that's mined as well. It requires, obviously, basically all of the same infrastructure as mining uranium would, and processing. Now, in 2019, these are the best numbers I could find. 2019, the global mining operations for uranium equated 53,656 tons of uranium that was mined globally. 40% of that was in Australia, which we know has pretty strict environmental, rules. And something like 70% is from 3 different countries, and they're all first world. They have very strict guidelines. Now, to put that in perspective, in 2019, 140,000 tons of cobalt was mined, and 70% of that came out of the Congo. So you're not saving the environment with solar panels.
Right. Yeah, no, yeah, that's actually really interesting, because I was going to say, when it comes to uranium mining, the 3 major producers of it are Australia, Canada, and Kazakhstan. And Kazakhstan has exponentially different standards than Canada or Australia do. Australia is such a fantastic model for us to follow, because not only do they have much, much better standards and practices when it comes to their environment, they also have exponentially better standards when it comes to safety, because mining is also an inherently dangerous thing. And they've shifted well in advance to most everybody else to a far more automated mining system than we use here. So that really mitigates the potential loss of life in the process of mining itself. But yeah, that's always something to consider, is where is it coming from, and how does that country or nation respond to it? What kind of practices and standards do they have? Kazakhstan, that's a different animal than Canada or Australia, for sure.
For sure. For sure. But we could, in my perfect utopia, America would overtake Australia and Canada and Kazakhstan, and we would, mine and we have plenty. It's not like uranium is a mineral that we're running out of. There's plenty right here. Just in New Mexico, Arizona, Utah, and Colorado, there's enough to power the planet for basically forever.
Right.
Obviously there would be huge mining operations that would take place, but most of these places too are not places you want to go visit. It's not like they're the prettiest spots.
Yeah, exactly.
So as far as the the environmental impact of mining, as you stated, you're going to have that. But no matter what your operation is, maybe tidal might be, but you can't even, garner tidal energy without mining operations to build out, your infrastructure for that. But it just seems to me that, if we were to really push policy, especially from the libertarian side, and this is where I really got involved in it, is that I do care about our environment. I do know that, temperatures are going up. I don't think it's as dangerous as they say it is, just based on, reading and research. But it will have impacts, that's for sure. And I don't even know that we can actually stop some of those impacts at this point. It may just happen no matter what. But to me, it seems to me like if we're going to, the Libertarian Party as a whole doesn't really have a very good message when it comes to energy. And that is a huge question to a lot of people. What is your plan for energy? And the message from the Libertarian Party has always been, well, the market will figure it out. And sure, they would if you got out of their way. But that's not what people don't respond to that. Most people want to be told what to do. Strange, I know, but most people don't want to be free. That's made up. And so I wanted to get the Libertarian Party on board and get talking to people that know what they're talking about, because I believe that the party as a whole and as a platform should push nuclear, and for the reason that it's environmentally better. And it's also better for human rights. Cobalt, 70% comes out of the Congo. They don't have the best track record as far as human rights go, which is something that Elon Musk tweeted, and he got massively ratioed. Was he had said something about they were no longer going to use Bitcoin because of the environmental impact of the mining operation for Bitcoin, and that most of it's powered by coal, right? And I'm like, okay, really, dude? Like, do you know where cobalt comes from that you're buying, and who's digging it out of the ground for you? Like, stop it. But even from that argument, even if you want to make an environmental argument that, it takes more and more and more and more power for them to mine out a Bitcoin now, which is true, that's literally by design, then, okay, more nuclear. That's how you handle this situation. And something I didn't know, and I recently just learned, that with the technologies, as well as they've been developed in the nuclear fields now, if you were to build a power plant, even just out of what we have now, that power plant will still be active and operational a century from now.
Right.
So when the last Bitcoin's mined, we could build the power plant tomorrow that use the power or produces the power to mine that final Bitcoin in 2141 or whatever it is. But I don't know if you know this, but do you know how long a solar panel is actually good for?
Oh gosh, I don't. I thought it was only going to be for probably about, God, I don't know. I mean, you have to replace so much on it. And I was under the impression that it was maybe a yield of about 5 to 10 years before you have to do R&M on it. And like, it's not as long. And there's always constant update and upkeep that has to be done.
Right. And your overall best value is probably 30 years from the time you have it installed or install it yourself, whatever the case may be. So, for the cost right now, and this is one of the things people say is, well, as technology gets better, they'll get cheaper. That's not true. They're as good as they're ever going to get. We would have to either develop or discover a new element to make them any better. And the odds of that aren't very great. And even if you did find a new element, it doesn't mean it's going to be any good for that. You know what I mean? And so you're specifically looking at about 30 years. And I actually had a conversation with a guy that installs solar. That's his job. And he told me, you're never going to get your money back. It's never going to happen. So when you hear all these stories that are like, oh, well, you can sell it back to the grid, and nonsense. It's absolute nonsense. He was like, if you try to build your house to where it solely runs on solar, you've got a battery backup, you're never going to get your money back. You're never going to save enough because you're going to have to replace them.
Right. And I'm under the impression too, and I might be wrong about this, but I was under the impression too when it comes to solar that the amount of footprint needed and so the square footage needed in order to get you that energy yield to power your home is not going to be it's going to be larger than the footprint of your home. And so you're always going to have to supplement with energy that's taken from the grid. So it's never, to my understanding, and maybe there are some folks that are 100% solar. It's possible, but I imagine that they have a much larger footprint that they can do that with. But in your typical home, you're still going to have to offset it with energy from the grid.
Right. And so again, not only are you never going to get your money out of what they cost you, but you're still buying, that coal power or whatever. So to me, I think, and this is one of the things that's just super irritating to me is that, and I recently just learned this, that the rolling blackouts that you see in California, at least twice a year, generally in the fall and generally in the summer, which by the way are lethal, because there are parts of California that, like you said, they have the same problem as Arizona. If your AC goes off, you could die. Like, this is a real thing. It happens every year there. But it was because of their solar and their wind and their push for these green technologies, right? That destabilized their grid. And so you're literally killing people with these green techs at this point. And I find that just disturbing that politically people are like, well, it's still better. No, it's not better. We could build a nuclear power plant, I think I believe it was like if we had 3 per state, we would have enough power to do anything and everything we wanted. And that's it. I mean, we would no longer need the natural gas power plants. We wouldn't need coal power plants. We would have all the power we ever needed. And then if you wanted to waste money on a solar panel, go for it.
Right. It's fun. I like to collect.
But here, this is something that you probably would have some knowledge on. What level of subsidies do mining operations get, if any?
To the best of my knowledge, they don't get any. I don't think that they get any. I think that, I would have to really research that. I don't know that answer off the top of my head, but I don't think that they do. I think that it's usually a big conflict between government and the mining industry because of the environmental issues and of course because of the health and safety concerns as well. Like I said, mining is an inherently dangerous job. So you're working with explosives, you're dealing with heavy rocks. There's so many things that can happen. Although the largest cause of fatality for the mining industry is usually issues with powered haulage. So things like, somebody's pickup truck getting run over by one of those 800-ton haul trucks. They can't see you. It's a horrible thing, but they can't see you, or going over a berm or something like that. Those are usually the highest cause of fatalities. But in Arizona, there's a lot of conflict between legislators and the mining industry because of those issues, those concerns. And those are grossly overinflated because the issues of environmentalism and health and safety have become so politicized to the point where we're ignoring base data. We're not looking at the actual number. One of the biggest things here in this discussion about nuclear and why this is a far superior alternative to some of the greener energies is, again, you have to look at yield. How much impact to how much energy yield? If it's comparable on the impact, but the energy yield is exponentially more in nuclear, then that's going to be an exponentially better, greener technology than, say, using solar or wind or any other form. So. Right.
And I think a lot of people don't seem to understand that about basically every industry is that you have to look at, energy in for energy out. And so that's all profit is energy in for energy out. And you got to make sure that the more energy you're pulling from something for the least amount you're putting into it is better in every possible way. That's why capitalism actually works. You put stuff in, you get stuff out. As long as you get out more than you put in, you're winning. And that shouldn't be considered a bad thing. And so
that's just being super efficient, and efficiency is going to be what's greener. Like, you're right. The goal in capitalism is to increase your bottom line. And the way you increase your bottom line is that what you're putting into it is less than what you're getting out of it. So, I mean, that's why mass production was such a huge deal, is that they were able to create more using less labor, less effort, by streamlining that mass production process. So this is one of the benefits of capitalism. I do think there should always be that continuing dialogue, where we do, as a society, evaluate these things, look at them from our integrate all the updated data that we get, and evolve our thought process and encourage businesses, by our patronage or lack of it, to improve their standards and processes too. But a good entrepreneur, and we have many, are going to look at that bottom line and see that the best way to do it is the way where you get the most out of the least amount of effort.
Right. And energy, that's the basic idea. And one of the things that I wanted to touch on, and I recently learned this, was that your solar panel, say, however big it is, you only get about 20% of the actual power that hits that panel is collectible. So 80% is a total loss. You're not getting that particular power. So your energy in for your energy out is awful. It's awful.
Right.
It's, you're literally in the negative, basically, at that point for what you're getting. And on nuclear, it's 50-1. So for every energy input of 1, you get 50 energy out of that. That just alone is such a massive difference. As well as the long-term ability for it to continue to operate at capacity. The part of the issue I know is that, one of the things that Mark had told us was that once you apply for your license, they don't even look at it for 3 years. There's just some weird rule where they're like, well, okay. And they just sit on it for I don't know why, you could be done building the entire power plant in the time that the NRC just sits on it. They just have it. And they don't even look at it. There's no reason. I don't understand the reason.
Is there a bureaucratic backlog, or is it just that they have a moratorium of 3 years?
It's a moratorium of 3 years, and I have no idea why that rule's in place, but it is. And that's bureaucracy at work, really. Is we'll have this stupid rule, and no one will know why.
If you still want to build a power plant in 3 years, then we'll talk.
Yeah, then we'll talk.
Yeah. None of these whims.
What's interesting about it is that they always approve them.
So it doesn't matter.
It's I don't understand it, but it's incredibly odd to me. But most of the things that government organizations do are odd to me. But as far as I want to go back to these subsidies for just a moment as well. The green technologies are so subsidized by both state and federal government that alone tells you they're inefficient, because government subsidizes crap that's inefficient. I know most people say, well, it's worth it. No, it's not, because you're buying this power twice, actually 3 times, really. If they subsidize it and they build the solar farm in Arizona or whatever, then you built it. You paid this company to do something that you didn't even need, or want, and it's not effective. And then you have to buy that power from that company. It's ridiculous. Why are you paying to build something that you have to then purchase? It's retarded to me. And that's why I say subsidies are the worst thing government does, because it only allows bad technology to take hold.
Right. And if you're not looking at the impact, like the other thing too, is that if you have taxpayer money going to subsidize these companies, then you should probably drill down and determine where those taxpayers got their money, which means that they work in a whole host of industries which are going to have an environmental impact. So if you really want to get into the environmental impact of the wind and solar industry, you have to look at all that data, like what all goes into not just the fabrication and manufacture of these solar panels or these wind turbines, but the money that we needed in order to salt this enterprise comes from a whole host of industries as well, which have an environmental impact. So it really is just, I mean, it is, as we call in my industry, a turkey. Like, this is not something that you want to pursue. You lose your ass every time.
Right. And so we're coming up on our hour here, and so I wanted to just restate that one of the things that when we had talked on the phone is that you had said something that made me laugh, that as you had stated earlier, that if you can't grow it, you have to mine it. That's the only way anything happens. So if you like that cell phone, congratulations, you support mining. Whether you like it or not, you support mining. Even if you support solar panels, you support mining. And so as far as the environmental economic impact side of the nuclear argument, it's a non-issue, because it doesn't matter what your opportunity is, it requires mining. And as you had said on the phone, things don't just appear from magic.
Yeah, nothing's born in a vacuum.
But if you were to take someone from, say, 250 years ago and bring them into today's world, they would think it was magic. And it's just called technology. Yes, they would. They'd be like, oh, these witches, they're all witches.
Sorcery.
Yeah. So no matter what, the home you live in, the car you drive, the everything. I mean, when you go to that grocery store and get that food, whether you like it or not, that food came from growing and mining in a lot of situations. So oil drilling, I don't think most people know this, but almost everything up to and including this conversation that we're having would not be possible without oil right now.
Oh, yes.
And so when people go, well, oil's bad. Okay. That's one of those things when they tweet nonsense, like, well, we have to ban oil or ban fracking. I'm like, okay, well, turn your phone off, because it doesn't exist. You know what I mean? It doesn't exist without mining.
And bitch about mining.
Yeah, it does. It's like, okay, you don't seem to understand. You couldn't do that without mining. You couldn't do that without oil. Now we are being. I was reading an article the other day that they are becoming much more efficient at synthesizing oil, as opposed to drilling for it. Right now, it's not economically viable, but the more that they put into it, who knows? Maybe it will be one day more viable. I like the argument of using hemp to make plastics better. It's way better for the environment, and you can grow plastic literally. So it's not that. That seems like an argument environmentalists would be pushing. They don't seem to be, and that's odd to me. But I just want to let you finish up on and making it more than clear to people that nothing in their life would exist in their, what makes them comfortable in their life without mining.
Absolutely. There's actually something that you guys might want to check out if you have Netflix and are able to get it. There's a wonderful 2-part series that's hosted by a materials engineer called Everyday Miracles. And the first episode, it talks about what's typically in your home environment and what those materials are and where they come from and how they're made. And then the second one is things away, like transportation, etc. But all of that, and what makes it so absolutely brilliant, is that it drills down into how these things were discovered, how they were created, where they come from. And so it's really, really important, I think, especially today, because in the United States, we are going to ultimately face a really big economic downturn / depression that is going to negatively impact all of us. Is you need to understand your supply chain. You need to know where everything you're getting comes from. And then you have a decision to make as a consumer about whether or not you want to patronize those businesses. Our entire world is filled with materials that come from plastics, which comes from petroleum, and of minerals that come from mining, as well as, of course, things that are grown like wood and plants and stuff of that nature. All of that comes from our environment. And in order to use it, there is going to be an environmental impact.
Yes, and that the best argument, if you care about the environment, is stop being so fucking wasteful with stuff. People that buy things and then just throw it away, spend the extra money for the better product that's going to last longer. Stop buying all this cheap garbage at Walmart that's made by slaves. It's nonsensical to me. And as far as, like you said, even like wood, sure, wood's grown, but you can't really form wood into much without tools, and tools require metal. Mining.
Yes, exactly.
So everything is always going to come back to either growth or mining. So the best thing in my opinion, that we can do as people to be better to our environment, to be better to our brothers and sisters around the globe, is be less wasteful.
Absolutely.
And grow your own food if you can. You can grow a lot of food in a very small space. Most people don't realize that. Use glass, not plastic, things like that.
Right.
There's a lot of ways to be much better in your environment than just saying, well, oil's bad, we should get rid of it. That's not going to do what you think it's going to do. I think it was Greta Thunberg at one point had said, we can't wait till 2030 or 2040. We need to end fossil fuel production right now. And I'm like, why do you want to kill 3 billion people? That's insane.
She says after she flew across the country on a jet plane.
Exactly.
Like, okay, I get
Yeah.
you, sister, but let's own the irony. And every single
Right.
person, you're right, we all have an impact. And the best way to do it is I think we should shift more toward a craftsman style economy where we are buying superior products that are going to last longer. So our waste is much less.
Right.
And look at companies that are able to create less waste. Like that's really the key.
Right. My argument is always, don't try to get the government to do something, just get the business to do it. You can do this. It's, I know a lot of people, especially the Republicans, for instance, hate the boycotting thing. Well, it works.
It's a very effective way of signaling our displeasure. Like it hits you in the wallet and it makes you change.
100%. And, I don't always agree with why someone's being boycotted and then capitulating to crazy people, but it does work. It is effective. So stop going to the politician and trying to get them to control everything. Just go to the business and say, look, I'm not happy with the way you're operating, operate better. They will. And that's why capitalism works.
There's something I want to say on that note about going to politicians. It should be understood that the biggest cause of environmental disasters in the world has been governments. So in the United States, most of our Superfund sites are the result of government issues. Right, and then we turn around and ask the very same agency that destroyed that environment to fix it. Like, why would you go to the people who perpetuated the problem to fix it? Like they should have just done it right to start. Or exactly.
It's nonsensical. And the number one way you can help the environment from the American side, number one way is, and this is something you can use the politicians. In fact, you should make it very clear to them to stop fucking bombing half the planet. That's very bad for the environment. Yes. And those missiles require mining. So you're supporting mining, whether you like it or not. Anyway, this has been
celebrate your country and the world by blowing up a small portion of it.
Yes, exactly. I mean, because environment and reasons or whatever. But that's, it is important. Just be better, buy better. Like you said, start supporting a craftsman type economy. Not to mention, you're not going to have a choice in that matter very soon. Anyway, I read a thing that said that we can see as much as a 30% decrease in the market by the end of this year. To put that in perspective for people, that is way worse than the Great Depression was. That will be a devastating situation. So just be better prepared for things and buy better quality products now while you can, because you might not be able to. That's just a thing. And just know that uranium is better. It's just better. As Kim had said, energy in for energy out is exponentially better than all of our other options that we have. So right on, Kim, this has been awesome. If you have anything else you want to say or anything you got going on where people can support you or anything, I know you ditched all the social media, so.
Well, I wanted to say, if anybody who watches this if there's anything that I may have misstated or there's some additional questions you might have and you want to reach out to me, you are more than welcome to email me at kim.ruff as in Frank 2016@gmail.com. I'd be happy to take a look at it. I'm absolutely fascinated with mining and minerals and elemental chemistry and all that stuff. So anything that you want to share with me that I didn't know or anything you want me to clarify for you, I'd be delighted to do. And I appreciate the opportunity to be on.
Right on. This was super fun. Maybe we'll try to get Kim on with Mark one of these days, or her buddy down there and talk thorium. So, well, he'll talk and we'll listen.
Right. I'll take notes.
Anyway. All right, guys, this has been awesome. I will get Kim's email in the description of this video so that you guys can, I'll hyperlink it so you guys can email her if you have questions or anything like that. Thanks for watching, everyone. Bye.